Hi, algebra students. Welcome to today's lesson on applications of linear equations. So the main topic for today is when we are given a scenario where they're comparing quantities, and I should have been more specific in the title. So these quantities are going to have the same units. Okay, so keep that in mind. We're talking about the two quantities. They're going to be in the same units, okay? Which is why we're going to use the same variable. So just pay attention to whether they're telling you about a relationship between two quantities that have the same units. We're going to write an appropriate equation that describes the relationship, and then we're going to solve it, but make sure that you always give your answer with the correct units. Okay, so always make sure you include the correct units. Previously, if we found an answer like x equals negative 2/3, we'd leave it like that. But now, if we get an answer, we want to make sure we say, is it dollars? Is it shoes, etc., right? So there's going to be different units. Okay, so go ahead and pause the video and underline anything that you see in this problem that's related to something we've learned about in terms of vocabulary, or anything else that you think is important. So pause the video right now, read the problem, underline any key words or circle things that you think are important. Okay, so as you can see, I underlined and circled a couple things, or highlighted. For one, I wrote down what Monica's gift card was worth. So pretty much any number that you're given, you want to circle it to see if it's going to be important when solving the problem. I also noticed a couple of vocab words from our previous lesson: more than, some, and is. Okay, so the question is, what is the value of each person's gift card? Okay, so we don't know right now. So what I like to start off with is kind of label everything. So Michelle and Monica. We're talking about Michelle and Monica. Because they're comparing their gift cards in terms of money, they both have the same units. We're going to say, okay, well, they both have a gift card with money on it. But then they told us that Monica's gift card is $15 more than, or has $15 more. So I'm going to go ahead and put $15 plus 15 because the word more than, or the phrase, means addition. A couple other things they said was the sum of their gift cards, plural, is 75. So remember that addition also can be represented with the word sum, and is means equals. So together, the sum of their gift cards, so the sum of Monica and Michelle's gift cards is 75. Well, remember, Michelle is going to be represented by the variable X, her gift card, and Monica's has $15 more. Okay, so now we have an equation that we need to solve. X plus 15 equals 75. So now you just use previous strategies that we've been practicing, combine like terms. X plus x is 2x. Subtract 15 from both sides. You get 2x equals 60. And then divide by 2. So what have we just found? We have found the value of x. We can use this to substitute the values back into the original problem. So look at the left, right? We're going to substitute what we found. Remember that x is 30. So if we're going to plug those values back in, x is going to be 30, which is Michelle's gift card amount, and Monica is going to be x plus 15, so 30 plus 15. And that's all you need to do, right? They asked us how much is each gift card. So Michelle's gift card is 30 because X is 30. And Monica has $15 more, so that's 45. Okay, so think about what we did. We read through the problem, we circled and highlighted or underlined important words, phrases, and numbers. We set up an equation using the same variable, and we solved our equation. Don't forget the correct units. Notice that I put dollar signs on my answers. All right, let's do the same thing for number 2. Read it through, so pause the video now. And circle, highlight, or underline anything you think is important, and when you're ready, push play. Okay, so this problem is comparing Michael Phelps to Nellie Coughlin, which were very famous swimmers for the United States in the Olympics. They both won medals, okay? If you notice, they use the word total, a total. There's also a couple numbers that were important, a couple phrases that were important. Now, this number is kind of hidden, but it's in there. Phelps won 5 more medals than Coughlin. How many Olympic medals has each athlete won? Well, they both won medals, but Michael Phelps won 5 more medals than Coughlin. So 5 more than. Remember that more medals. Okay. And then together, the total is 27 medals. So we're going to go ahead and write that. Now, when you go shopping to the grocery store and you're buying a lot of things, and your receipt should say total. The total is given by adding up all the things that you bought, all the items. So when it comes to totals, they're also adding things up and giving you a final sum, okay, a final answer. So they're saying all together, that's 27 medals. All the ones that Michael won and all the ones that Natalie won. So Michael won X plus 5 and Natalie won X. So do the same thing that we did in the previous problem. Combine all the x's, so we have x plus x, which is 2x, and the 5. Subtract the 5, divide by 2. Then we're going to go ahead and substitute that back into the original problem. Okay? So if x represents 11, then that means that Michael had x plus 5, so 11 plus 5 medals, so 16 medals. Oops, didn't give myself enough room. And Natalie, who was just representing, we were representing her medals with X, so that's going to be 11 medals. And that's it. So again, we're setting up an equation, solving it, and then once we have our answer, we're going to substitute it back into our original relationship that we established. Okay, let's do the same thing with number 3. Read the problem, so pause the video, read the problem, underline, circle anything that you think is important, then push play when you're ready to work it out. Okay, so plumbers use PVC pipe all the time. PVC pipe is like, it can come in different colors. Mostly it's white and it's like a plastic type of tubing. Feel free to Google it if you want. So we're talking about 2 pieces of pipe. We're going to just call it first piece and second piece. Okay. They're both being measured in feet, so same units. But we know that one piece is 2 feet less than the other. Okay. Now, it doesn't matter which one you decide is going to be shorter, but clearly one piece is 2 feet less than the other. I'm just going to go ahead and make the first one the shorter one, but it doesn't matter. And then we know the total of theirs, of the pieces, the total length is 12 feet. Okay. So I'm going to go ahead and set up an equation. We know the total is 12, and then we're just going to put in our values, x minus 2, which is the shorter piece, okay, and then the longer piece. Okay, so we're going to clean it up, combine like terms, add the 2 to both sides, and divide by, or sorry, yeah, add the 2 to both sides and divide by 2, and the final answer is going to be 7. So we're going to go ahead and replace that back into our original hypothesis, that our original comparison, that the first piece is going to be x minus 2 and the second is going to be x. So the first piece is going to be x minus 2 feet long, so that's 7 minus 2, which is 5 feet. And the second piece, which is the longer piece, is going to be just x, which is 7 feet. Okay, let's do the same thing, follow the same process for the last one. Go ahead and pause the video, look for keywords. So twice as many credits is a really important word, twice. How many credits does each person have if the sum of their credits is 51? So here are a couple of important words. Now, when someone says twice as many, okay, that means, for example, like if you are, let's say you have 3 pieces of gum and I have twice as many. That means I have 2 times as many, okay? So 2 times. That would mean, right? Remember, if you have 3 pieces of gum and I have 2 times as many or twice as many, that would be 6. Okay, so let's set up our equations. We're talking about Terrence and Janae who want to graduate from college. They both are earning credits, except Terrence has earned twice as many. So we're going to put 2 in front of the variable to signify the multiplication of 2 times x. Just so you know, you could have also done x plus x, which is 2x. But most people, when they say twice, they think of 2 times versus adding something 2 times. Okay, we know that the sum of their credits is 51. So when you add Terrence's credits plus Janae's credits, you get 51. Notice that these are like terms, so to solve the equation, just add those up, divide by 3, and you get 17. So if you substitute that back into your original equation, Terrence had 2 times x. So if x is 17, 2 times 17 is going to be 34. And Janae is going to have the 17. And I almost forgot my units. We are going to take off points if you don't put correct units. So these are credits, not chickens, not horses, credits. Okay. For the next one, go ahead and pause the video, push play when you're ready. Let's do the same thing we've been practicing, underline and highlighting and seeing if we can set up a relationship and equation. Push play when you're ready. Okay, so this electrician has a wire that he needs to cut into two pieces. So I just call the first piece and second piece. We know that the total of the pieces is 45. But one piece has to be double the length of the other. So one piece has to be twice as, right? Double is the same as twice or two times the other. So they can say twice as big or double the length. Now it doesn't matter which one's bigger. I'm just going to go ahead and make the first piece bigger. And then I'm going to substitute those into my equation. Notice I've got some like terms. Divide by 3 and you get 15. So what are the lengths of the pieces? The correct answer is one is going to be 30 inches and the other one's going to be 15. As always, if you guys need any extra help or have some questions, feel free to reach out. Talk to you soon.